everyone, this is Janice, and I'd like to introduce you to my husband, Brad.
Hello, Sparrows.
We are both scientists, real scientists, and we have great chemistry together. So we know everyone loves to have fun and loves to make a big giant mess and get excited when wild stuff happens. So we have some exciting things planned for you today. But we don't want anyone to get hurt, and we certainly don't want anyone to get in trouble.
We want everyone to stay safe.
So please don't try any of these things at home alone, okay? Okay, Brad, here we are again. We are going to make something called elephant toothpaste.
Elephant toothpaste?
Yeah, believe it or not. Do you think elephants actually brush their teeth?
Well, I don't know. I've never seen an elephant brush their teeth.
I don't think they really use this to brush their teeth. But anyways, it's fun and we're gonna do it.
Okay.
So first we're gonna take some hydrogen peroxide and we're gonna put it in that bottle.
Okay.
And this hydrogen peroxide is made of hydrogen and oxygen.
Okay.
Now we're going to put 10 drops of the blue
Food
coloring into the bottle.
One, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay, one for extra measure.
Yep, one.
Then we need 1 tablespoon of my favorite dish soap, Dawn.
1 tablespoon of this?
Yes, the tablespoon is in the water right now.
Okay.
You want me to squeeze the bottle?
No, I got it.
Looks like an interesting mix.
Yep.
And then swish it around.
Swish it around.
Not something you would drink.
No.
You'd get very, very sick if you drank this.
Yep.
Or ate it. Something only for scientists to be messing with.
Yes.
And this is not for humans to brush their teeth
No,
with either.
it's definitely not.
Okay, I think you're good.
Okay.
And now you need to pour the yeast and water mixture into it.
Okay.
That's in the little yogurt container. And try to do that as quickly as possible. If it works,
Well.
I would not hold it. Oh, look at that, it's
Something's
working.
happening.
Something's happening. Look at that. No, don't mix it. There it goes.
Oh, it's going.
There it goes. Elephant toothpaste. Wow.
That would clean a lot of teeth.
Yeah. Well, you know, elephants are big and they got a lot of teeth, man. There you go. It's still flowing out.
Wow.
Yeah. Wow. It'd be nice if it was multicolored. Look at that.
Wow.
Now that's a reaction if I've ever seen one.
Yes.
Maybe we could pass this around to the sparrows. There you go. Look at that, you guys. It's still coming out.
Yeah.
It's still coming out.
Yep.
Why don't you put a drop of the blue on the top of it and see what happens? I'll see it when it's spreading. It's like a mini volcano.
Yes.
Well, it's slowing down.
Yeah.
This is the experiment. Now we've got to go find ourselves an elephant. Brush his teeth.
Hey, hello sparrows. Our next experiment is groovy blobs in a bottle.
Or as some would call it, a lava lamp, but I think maybe only Nick and I know what that is.
Yes, we're going to make our homemade version of a lava lamp, which, and if none of you have seen that, you're in for a special treat. So in this experiment, we're going to mix water, which is what I have here, in a bottle. And about a quarter of the bottle's filled. And then here's the oil.
And this oil, by the way, is bad oil, so we're not wasting good oil
Yes.
making this. Wow, that looks pretty gross, Brad.
Yes, I know. Let's see, just a little bit more.
So what's happening here, Brad?
Well, the oil is lighter than the water. So as you can see, the water is at the bottom. And then the oil floats on top. And now we need to add a little food coloring so it'll be easier to see when we form the bubbles. 1, 2, 3, 4, 5. Notice that the food coloring is dissolved in water, so it's sinking to the bottom.
Yeah.
And then the purple and blue, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
We were hoping to try to make purple.
Yes, we're trying for purple here.
Yeah, and so purple is like red and blue mixed together. So we'll see if that worked out. This oil is pretty wild color. What happened to the dye? I don't even see it.
I don't know.
Can we let the sparrows see where the olive oil is?
Yes.
See, look at it. It's like just one big blob.
Okay. So now we're going to add the fizzy tab.
And we're supposed to break it up.
Yes.
So I'm going to go in here real close so everybody can see it. Huh?
Anything happening?
Well, I saw... Oh, something's going on. Dye is coming down to the bottom.
Yeah.
And I see the red separating. Now it's coming up.
Are there any bubbles forming?
I don't see it permeating quite yet through the... Well, I see some small bubbles through the top, but no color.
Maybe we need some more fizziness.
Yes, let's put some more in.
Yeah, starting to get some bubbles here.
We have an awful lot of oil for it to permeate through.
Yeah. Okay, now we're getting some bubbles.
Yep. Let's see if the color starts coming through here.
Well, we're getting bubbles, although they're not getting the colors that I would like. Let's see what happens here.
Yes.
I saw a little bit of color come through. I see a little bit of red in there.
Oh yeah, there's blobs. Can you see it?
Yeah, it just had to break through.
Yeah. It's not as successful as I thought it would be.
Yeah.
Okay, now we're getting action. Part of it is the oil is not clear, it's yellow.
Yes.
Okay, I think that's enough.
I just got it started. It looks cool with the blue and green.
Yeah.
It's starting to foam though.
Yes. So sparrows, if you notice that the water bubbles are coming to the top, and then when they break, they float back. The water with the dye goes back into the water layer. So you're getting an up and then down, up and then down action.
And why is that?
Because the bubbles that they form are less dense than the oil, so they float up through the oil. But when they reach the top, the bubbles burst, and then the bubbles that are part of the bubbles that are water reform as water and then sink to the bottom. So you get first the bubbles rise, then they burst, and then the water floats back to the sinks back to the bottom of the bottle.
Yeah, there's a lot of action in the top. It's kind of cool with the Alka-Seltzer. It's going to start fizzing over.
Yes.
Okay, well, I think that's it for this experiment.
Yep.
Any last words?
No, I think this was our homemade version of a lava lamp.
Okay, let's see what we got next.
Hello, Sparrows. Our next experiment is the invisible fire extinguisher, in which we're going to use baking soda and vinegar to put out a fire. Normally, when you're putting out a fire, you would either use water or blow it out like the candle on a birthday cake. In this instance, we're going to do something different. We're going to use baking soda and vinegar, which will react to form carbon dioxide. And that carbon dioxide will block the oxygen from the fire. Normally for a fire to burn, oxygen is required to support the fire. So once the carbon dioxide forms, it's heavier than oxygen and will block the oxygen from reaching the fire.
Okay, let's see if it works.
Okay, so here we have our candle. And let's make sure you get here close enough for everyone to see. Okay, now we need 2 scoops of baking soda, like you'd use for cooking. You just spread it around. Okay. Okay, so now we have baking soda and a candle. And now we want to add the vinegar, which will react to form carbon dioxide, which was heavier than oxygen, and so it will block the oxygen from reaching the fire. Keep your eyes peeled, we'll see if it works.
Let's see if this works.
Okay, here we go.
Wow! Oh!
Wow, that was fast.
That was fast.
So within 5 seconds of mixing the 2 ingredients together, there's enough carbon dioxide formed that smothered the fire and prevented the oxygen from reaching the flame.
Wow, I guess that was a successful experiment.
Yes.
Good job.
Action. Hello, Sparrows. Our next experiment, we're going to be making snow in July, believe it or not. And we're going to make this snow using a super absorbent polymeric gel and water. And this super absorbent gel is one of the materials that's found in disposable diapers. It's used in other things, but that's one application. And what's going to happen is that when you add the water to the gel, it moves from the outside of the gel to the inside in a process called osmosis, and that results in expansion of the volume of the gel up to 100 times. So let's see if it works.
Okay. So what are we doing here?
So we're going to take 3 scoops of this super absorbent gel and put it into
polymer.
Put it into the cup. So 7-ounce cup, making 3 rounded scoops. And okay. And now we need 7 ounces of water.
So let's see how accurate this guy is at measuring. Let's get this on 7. And we have to get it on fluid ounces on the carrot.
Okay. Now we need
Weight.
Okay, 7 ounces.
7 ounces.
What have we got so far?
5. 5.1. 6.3. 6.8. Oh, 7.13. That's good.
Okay, that's close enough. So,
Close enough for horseshoes.
Sparrows, keep your eyes on this because it's going to occur very fast. So I'm taking the water, mixing it with the gel, and here we go.
Whoa!
Whoa!
It's like a giant snow cone.
It's like snow, but it's not snow because it's not really cold.
Wow.
But it sure looks like snow.
What does it feel like? Oh, it's kind of cold.
Yeah, it's fluffy.
Yeah. Wow, that sure made a lot. Is there any water left in the cup?
No, there is not. It's all snow.
And it's still making more.
Yes.
Okay, well that was pretty cool.
All right, so now we have a cup of snow in July, Sparrows.
Right.
Hello, Sparrows. Today we're going to try a little experiment that was done on a TV show called Mythbusters. As you may, for those of you who saw it, it was on that show, the candy was added to a bottle of Diet Coke, and that formed a fountain. And the concept was that the candy has little pits where it allows the carbon dioxide to form a gas, and that gas pushes out the cola out the top of the bottle. Now, today we're going to start with Lifesavers, a different candy that was used in a TV show. I don't think it's going to work, but Janice wants to try it, and so let's see what happens.
What are you doing, Brad?
We're putting on a thing that's going to allow the candy to drop into the cola, and then if it works, if this Lifesaver candy will work, then from the fountain, I actually don't think it's going to work, but I'll give it a try, and we'll see what happens. So let me know when you're ready.
Okay, I better back up just in case it works. Up, whoa! Okay, well, I guess I was right. It did work.
Here's the real experiment. We're going to use the same candy as is used on the TV show Mythbusters, and in order to make it easier to see, we switched to a green top that has 3 holes that'll make the fountain much easier to see. It'll be more spectacular. So let's see how it happens.
Okay, I'm gonna back up this time because I think this is gonna be wild. Whoa! So, let's see what happened here. So, you pressed it too fast, and soda started spurting out really fast, but there's not as much soda left in the bottle right here compared to the other bottle, which,
Lifesavers.
well, Lifesavers was kind of a dud. There's a lot of soda left in there, but that did burst as well. So they both worked, but really, the Mentos worked better, right, Brad?
That's right. The Mentos fountain was about twice as large as the Lifesaver fountain.
Yep. And the other thing is you don't want to use the green Mentos because they're dipped in
Wax.
And unless you like eating candles, you probably don't want to eat that candy either. Okay, we're loading the Mentos in. Tell me when you're ready to pull the pin. 3.
Okay. Ready?
Yep.
Okay, Sparrows, here we go. 3, 2, 1.
Wow! You guys see all that? Look at all that carbon dioxide in that bottle.